All right, this is the next video. Find the cubic root of z is equal to 2 plus 2i. So again, just like example 8, we're going to find just the cubic root, so they only want to find the cubic root. Let's just find the 3. Find the 3. So we're going to do this instead of doing it 6 times, we're only doing it 3 times here. So again, first thing we do, 2 plus 2i. We're going to find our modulus and our argument. If we graph this, it would be here, so 2 and then 2i. It will be within the first quadrant. Keep that in mind. We go ahead and find the modulus by squaring both of them, and then you end up with square root of 8. 4 plus 4 is 8, and this simplifies to 2 radical 2. So our r is 2 radical 2. Next thing is your tangent. So the tangent is equal to b divided by a. b is 2, a is 2, and that equals 1. So again, you're looking in your chart to see where tangent equals 1, and you look in the first quadrant when you graphed, and that would be the 45 because it's the same number on top and bottom. So it'll be radians over 4. But in this case here, I'm going to go ahead and convert it to 45 degrees, and I'll show you why later. So here I have 45 degrees, and I have my modulus. So in polar form, this is equal to 2 radical 2 times the cosine of 45 degrees plus I sine 45 degrees. So then we have that. We go ahead and now we apply the cubic root and apply everything else to it. So now, to apply it, we're going to find the first one. I'm going to make it really big. The first one, which is, we're starting at 0. It's going to be 2 times radical 2 to the root power, so it's 1 over the root. And in this case, it's cubic, so it's 1 over 3. And then times the cosine. For this, since we're all converting it into degree form, you're going to do your degree, which is 45, and divide it by your root. Your root is considered 3. And then plus 2 radians is considered 360. So you're going to do 360 times whatever your k is. In this case, your k is 0. Again, you're always dividing by your root. So you're going to have that equation there. So the only difference, you're just converting this into degree form. And then the sign is always the same thing. So the sine of 45 divided by 3 plus 360 times 0 over 3. So then you end up with that whole equation there. You go ahead and simplify. For this, let me show you how to simplify it. We have 2 times radical 2 to the 1/3 power. If it's in fractional exponent, let's put everything in fractional exponent form. According to this, we have 2 times 2, this is one number, it's a whole number, and then this radical 2 can be put into exponential form. The exponential form of the squared root is considered 1/2. And remember, when you have a whole number, let's say we have 5, that in reality it's actually 5 to the 1 power. We just don't show it. So in this case here, it's the same exact thing. We have 2 to the 1 power. And remember, when you're multiplying numbers with the same base, you add the exponents. And when you add the exponents, you have 1 plus 1/2. And that's going to give you 2, 3 over 2. It's going to be 2 to the 3 over 2 power times a 1/3. And the last step for exponents, you do 3 over 2 times 1/3. And when you multiply those two numbers out, you end up with 2 to the 1/2. And then, when we go over here, we go ahead and put it into the modulus form. We're just going to have the square root of 2 because that's what 1/2 is. So we're just putting everything in the exponential form and adding the exponents from here. So now, we went ahead and simplified that. We can go ahead and simplify even further. So the cosine, let's just work it here. All this work here. So 360 times 0 divided by 3, it's going to give you 0. And 45 divided by 3 is the cosine of 15. We do the same thing with sine, and then they're both going to have the same measurement. If you notice, 15 degrees is not in your unit circle, so therefore you have to use a calculator for this. So be careful of using radians form and degree form. I would prefer you using this in degree form. It would change your answer a lot if you put in radians. Now, we go ahead and we multiply it out. So I do the cosine of 15 times radical 2. So cosine 15, press enter, then multiply it from the answer by radical 2, and I always round to like the first or second one, and I end up with 0.38. So cosine 15 times radical 2, I get 0.38, and they have up to 4 numbers. I think I'll just have it as 2 numbers. And then sine of 15 times radical 2, I end up with 0.36, and then include your I because it's in complex form. So now I have that. So they want to find the 3 numbers. That's what your book has. So now I found W0. So here I should have put K, I'm finding 0, 1, 2. And then my nth root is considered 3. Now let's go ahead and find the second one. So I'm going to go ahead and erase this here. Go ahead and erase all this here. Erase this number here. So it's just like what we did before. So your K, you're finding the second number. So that means a 1. So this will equal to a radical 2, just like what we did over here previously. This is going to be converted to 1 and 1 because now we're finding the next number up. So we have the radical 2 here. And now we go ahead and work out our number over here. Okay, so we know 45 divided by 3 is 15. 360 divided by 3, I don't remember what number I got, but I got a certain number. When I add it into 15, I end up with 135 degrees. So my second number is actually in the circle. So if it's in the unit circle, I would use that radical. So when I use that, the cosine of 135, so I go to my unit circle, I find the coordinates, and then the cosine of 135 is considered negative radical 2 over 2 plus radical 2 over 2i. That's what sine of 135 is. So it's negative radical 2 over 2 comma radical 2 over 2. Now I go ahead and multiply it out, and when I multiply it out, radical 2 times negative radical 2 over 2. Radical 2 times radical 2 is considered radical 4, which will be simplified to 2. And then I'll have negative 2 over 2, and I'll just end up with negative 1. So again, you're multiplying the radicals there, or you can look at it as radical 2 squared, and they cancel out, and you end up with a 2. But you're multiplying it out, and from this case, 2 over 2 is 1, but it's a negative, so bring it down. In this case, same thing over here. It's the same exact number, but it's a positive, so I'm just going to end up with a 1 or a 1i. So radical 2 times radical 2, radical 4 divided by 2. Radical 4 turns into 2. 2 divided by 2, 1, and just gives you that 1i. And the last one. So we're going to go ahead and find the third number, which is 2, because you're always starting at 0. So when I go ahead and find 2, I'm going to replace all my k's from my equation up there. This will give you radical 2 from simplifying here. The cosine, so 360 times 2 divided by 3 plus the 15 degrees here, I end up with 255 degrees. And that is not in your circle. So if it's not in your circle, you're going to multiply it on your calculator. So the cosine of 255 times radical 2, so multiply this out and then put times radical 2. You end up with negative 0.37. And then the sine of 255 times radical 2, you'll end up with negative 1.37. They have 3, 3, 6, etc., etc. That's fine. Just simplify within the tens place, and I'll have that in your homework. So if you need any more help, let me know. Bye-bye.